Hi everyone, we are the Z Coders and we are here to present our project for the Smart India Hackathon 2024 under the Smart Education theme. Our problem statement is titled Learning App for the Deaf and Mute Students with Sign Language English Gujarati Converter. So we have many applications like Byju's and Khan Academy for remote home learning apart from the school for normal students. But have you ever wondered how these challenges are faced for the deaf and mute students? So this project aims to address the educational challenges faced by the deaf and mute students in Gujarat by developing a comprehensive learning application that leverages the modern technologies like NLP, AI, MediaPipe to deliver a more inclusive and effective learning experience for the students. Our proposed solution is a comprehensive learning app designed specifically for deaf and mute students in Gujarat. The app teaches Gujarati alphabets, basic mathematics, and science through interactive sign language modules. We have integrated the real-time sign language recognition and text-to-sign conversion using advanced technologies like MediaPipe for hand gesture recognition and NLP for converting the written text into sign language videos. Additionally, the app includes community support and collaboration features, enabling the students, teachers, and parents to interact and share resources. We also used advanced analytics to monitor the students' progress with personalized learning paths tailored to each student's pace and with the native language support. This application directly addresses several critical issues. Firstly, it provides the native sign language education, breaking down the communication barriers that deaf and mute students typically face. By bridging the gap between classroom learning and home practice, it ensures continuity in education. The app also encourages collaboration and social interaction, creating a supportive environment where students can learn from each other. Moreover, the advanced analytics provides valuable insights to educators and parents, helping them to address individual learning challenges. And finally, the personalized learning paths ensure that each student receives education tailored to their specific needs, enhancing their learning outcomes. Now, let's dive into the technical approach. We have developed the app using the Flutter Flow and Flutter framework for a cross-platform mobile development, ensuring a consistent experience across both Android and iOS devices. The backend is powered by the Firebase, which handles the real-time database management, authentication, and messaging, providing a secure and scalable data handling. For sign language recognition, we have integrated the MediaPipe, a powerful tool by Google that allows us to capture and analyze the hand gestures in real time. MediaPipe detects hand landmarks from each video frames, which are then processed to identify specific sign language gestures. We have also implemented the NLP models for text-to-sign conversion. These models process the written text, map these to corresponding sign language gestures, and generate videos that accurately represent the signs. In terms of the data storage, we use the Firebase File Store, which securely stores user data and analytics, enabling a real-time update and personalized learning paths. Now we'll briefly demonstrate our app prototype. So first we have to sign up with the mail ID. So once we have signed in, so we have to choose the language that we have to use within the app. So we choose English. So we get plenty of options within the app. So first we'll click on Learn. So we can see that we can learn alphabets, words, sentence, math, and science with this native sign language. So here we see that vowels and consonants have been alphabets, and each and every alphabet is provided with the video lessons with the set of words, with the indications of the particular symbol in the sign language. So once we have completed with the one lesson, we will next move on to the next lesson. So similarly, each and every alphabets, math, and every video lectures will be uploaded by a particular tutor or organized tutor. So in the practice session, we'll be practicing the quizzes. So in quiz sessions, basically a set of sign language videos will be provided, and the user should correctly recognize what is the particular sign and choose a word according to it. And in the writing test sessions, the user will be provided with a slate or a pad, writing pad. So when he writes particular letters or alphabets on it, basic NLP text recognitions will be used to correct the word or letters written by the user for the test marking. And then sign practice. For the sign practice, a set of words will be given by for the user, and the user should point a particular sign, and the signs will be analyzed by the models which are built for sign to text. So the signs will be analyzed by the models, and if the sign shown and the text matches, then a mark will be given for the user. So sentence joint. So basically, a set of sign language videos will be provided, and the user should particularly analyze the set of videos in the row and frame the word sentence by his own. So we can also take a test which will be contributing all the total parts and be used for calculating the performance of the user. So when it comes to conversations. So basically, we have a sign to text, which sign language uses media pipe to analyze the hand gesture points, and when the particular program gesture points map to a text, so that when you research them, it map to a particular text. So the text to sign similar to that, we use a bidirectional mapping. So a set of videos of the particular sign will be mapped to a text. So when a text is shown, the reverse mapping will take place in an order of sequential manner to frame the whole sentence, as the sentence is divided into small chunks or text, and each are mapped and bidirectional mapping in sequential videos only. So similar to that, text to sign, speech to sign are also operates in the same manner. The speeches are converted to text and later the sign. So next, we are moving with the performance. So the performance dashboard represents the performance of each and every person or the particular individual using the app. So here we see that it's a real-time performance maintenance. And then the support this it is a major impact on the students. So this community is basically for parents, teachers, and even HR recruiters from various companies and within the peers of the society. So here we can post any questions or doubt related to their needs. So here we see that a person asking a scholarship available for the deaf and mute students. So either a person can reply or another person can answer the questions, and also a person with if it finds anything useful for his community people, he can post the links, and also they can use accessible to it, and it will be better for its betterment for them. So next we'll see in the profile. So here in the profile, we see that basically the profile of the user, and here we can even change the language to Gujarati. So once it's changed to Gujarati, each and everything in the turns to the native language of Gujarati, which is very useful for them to access the language barriers. Then once we have finished it, we can also log out with it.
So this is a basic idea of how the media pipe works. So basically the media pipe is a module based on the Google's model, which is for hand recognition. So hand gesture recognition is done by marking the land points. So we see that I upload a video is divided into multiple frames, and each frame of the video is given a land points and the hand, so that hand gestures can be determined. So based on the angles and the distance between the points, the particular sign is detected based on the database through different database storage of a particular distance and angles. So this as a particular sign is predicted using the media pipe.
A solution is technically feasible as it leverages the proven technologies like Flutter, Flutterflow, MediaPipe, and Firebase. These technologies are not only reliable but also scalable, ensuring that the app can grow and adapt as needed. However, we recognize certain challenges such as ensuring accurate sign language recognition across different stages and maintaining high user engagement. To address this, we plan regular updates and improvements to the gesture recognition system. We will also provide comprehensive tutorials and customer support to help users adapt the technology easily. Additionally, we have designed the tutorials to be accessible and engaging, incorporating diverse content formats and interactive elements for the users. The impact of a solution is multifaceted. Educationally, it empowers deaf and mute students by providing them with the tools they need to learn independently and effectively, bridging the educational gap. Socially, it fosters inclusivity and improves communication between differently able students and their peers, teachers, parents, and HRs of different companies. The app also supports personal growth by boosting self-confidence and offering opportunities to develop the new skills. On the broader scale, the solution provides social benefits by integrating the students into a mainstream education and strengthening support networks. Economically, it increases employability and reduces the cost by offering digital resources. Environmentally, it minimizes the use of physical materials, reducing the paper waste through digital contents. From the technology standpoint, our app sets a new standard with advanced features and scalability. Adaptability and solutions are also contributing in community building by creating a collaborative and supportive learning environment. Lastly, the app demonstrates innovation by showing the application of AI and machine learning in education. Our research is grounded in existing studies and technologies. We refer to papers like Digital Tools with Inclusive Education, which explores the role of technology in supporting inclusive education for differently able students. Additionally, the study of Indian Gujarati isolated dynamic sign language recognition using deep learning provides a valuable insight into using deep learning for sign language recognition. This research helped us refine our approach to sign recognition. We also utilized resources from government initiatives like Indian Sign Language Research and Training Center and Gujarat State Association of Deaf. Online platforms like YouTube and ISL dictionaries for Gujarati were also instrumental in developing accurate and effective content.